here to tell about protein binding. Protein binding. Proteins, first we should know about proteins, why they bind and how they bind. How they bind? Proteins means a chain of amino acids bind together. See. Normally DNA undergo replication, transcription, translation, and mRNA will go to ribosomes and we'll get a chain of amino acids and we'll get protein. How these proteins are subunits of amino acids. These amino acids are main reason for protein binding. So normal skeleton and basic structure of amino acids. Depending on the carbon chain, different amino acids like glycine, alanine, tryptophan and different amino acids. This is basic structure. We have here two charges. These charges are main reason for protein binding. So normally even drugs, we have weak drugs, weak acidic drugs or weak basic drugs. They have even polarity, minus charge and plus charge. When they come near to these amino acids, they form bonds. Maybe these are reversible reactions. Maybe hydrogen bonding, hydrophobic bonding, not weak chemical bonding. In this way, the protein drugs are binded to the protein, and why they bind? There are some applications of protein binding. First, drug action. Carrier system. Excretion of drug. Bioavailability. Drug action. When any drug or tablet, when we take, it enter into our body and it bind to this protein. Not all the drug will bind to the protein, only some part will bind to protein, and not all the protein will bind to the drug. There will be some free proteins and some free drugs. Like if you write total protein used, free protein, this is the main reaction. So total, when any drug entered into the body, it binds to some part of protein and some free proteins will be left over. And not all the drug will bind to the protein and some drug total. This is another reaction, not total drug. Some bind to the protein and some it will be free and it show its reaction. Protein or drug which bind to protein will not show its reaction. It will be inactive or some form. And this is drug action. Drug action, it decreases the drug action and it makes the drug to be in our body for more time. Means we will increase the bioavailability. And carrier system. Some drugs are insoluble in our blood, and these, when they bind to the protein, they can easily travel from the site of absorption to the target site when they are not soluble in the blood. And excretion of drug. Rate of excretion of drug will be decreased when the protein bind to the drug, and it will be staying in our body for more time. And like same sustainable release concept and controlled release, only not, we'll take multiple dosage forms in a day. We'll avoid this multiple dosage form. We'll take one dose and make it to bind to the protein, and total day the dose will be released. This is some applications. And some in disease conditions, some particular proteins will be released in our body. When the disease comes to our body, some special proteins, like in heart attack also, there are different proteins will be released. For that protein, we can, this concept is used when drug is taken into our body, the drug will bind to the protein and reduce its reaction. Like that, we can also reduce the diseases. for protein binding kinetics. Kinetics of protein binding. This is a simple derivation. In any derivation, we should first know what is the basic equation, and if you know the last equation, it will be easy to derive a derivation. Here, normally protein and drug bind to each other, form protein drug complex. This is a type of complex. And one more. This is also one reaction, this is also reaction. But what is the difference between these two reactions? Anyone can guess? This is association and this is dissociation. You can find two different molecules bind to each other, form a complex of single molecule. Here a single molecule dissociate and form two individual molecules. Now we can write dissociation constant of this H less and Cl minus by total concentration. This is the dissociation constant. As this reaction is associated, we can change this. We can write association constant. This is main basic reaction of this derivation. From this, we should derive how much amount of drug binded to the protein of given protein. That is normal ED. This is total protein. This is amount of drug binded to the protein. From this equation, we should derive that equation. And if you know this equation and last, we can easily derive. Here we have a term PT, but in this equation there is no PT. We should include this term. We have free protein, and we know that the total protein is equal to free protein plus drug binder. From this equation we can include PT in this equation. How? If you send this one. This equation we include in this equation. So PD, instead of P we will write this equation. And done. We got all terms here. Now we should get this equation, final equation. We may be exchanging, we will send this equation this side, or by multiplying, or by addition, or substituting in both sides. Like we can do something to get this last reaction. So we need PD by PT. When we send this equation to this side, it gets multiplied to K. So K PT minus PD into W is equal to E. From this equation, we know we multiply this drug df with both of these, we will get equation A PT into df minus K that is equal we send this part this side. As it is minus here, it will do addition to it. Our last reaction is to get PD by P. Amount of drug binded to the total protein, and we have here we'll take here PD as similar and making it 1 minus KD. We got your PD. If you send this side, this PD will be left over. So, by 1 plus K is equal to P. We have PD, but we should derive for PD by PT. So we have this side. It is multiplying it out. If you take here, it will be dividing. So K df by 1 plus K df is equal to PD by PT. This is the last reaction. From first basic reaction, we derived this reaction. This is the amount of drug binded to the total protein. And this is a similar reaction to the Langmuir reaction, which amount of absorbent bait binded to the given unit mass of absorbate. Like for unit mass Y by Y. Same, this similar reaction will be fine. Amount of absorbate binded to the unit mass of absorbent. This also same amount of drug binded to the total protein. So we can plot a graph same making the temperature constant. We can plot a graph. So we are taking this PD by PT as R, substituting it by R. R is the amount of drug binded to the given protein. Same reaction. When we plot a graph between the amount of drug binded to the protein and free drug, we get this first isoderms. Here the temperature is constant and the amount of drug binded to the protein to the drug amount of drug available free at the tissues. This is just this is the kinetics of the protein binding. And these some factors affecting protein binding. They are main 5 physiochemical properties of drug and physiochemical properties of protein. Both will be involved here. If one they should be both mutually complementary, then only protein binding is possible. And some main factors are concentration of both protein and drug, and temperature, pH, presence of another molecule, structural changes. When we take concentration, there should be more concentration of protein and drug also. Then only protein binding will be possible. If both concentration are low, we will get some low amount of protein drug binding. So if the concentration increase, the protein binding also increases, and the temperature. This temperature is, when the temperature increase, protein binding will be decreased, because if you increase the temperature, the protein and the drug is binded with each other by weak chemical bonding or hydrogen bonding or hydrophobic bonding. So when you increase the temperature, the bond will be easily break and the protein and drug will be easily separated. So next, pH. When we differ in pH, when we will be keeping changing in pH also, the protein drug binding also will be decreased. The presence of another molecule. We thought that in disease condition there are specific particular proteins present. So we should bind with that drug and we should decrease the protein. If another molecule or any other drug ready to react with that protein without any specification, the protein drug binding, specific protein drug binding will be decreased and disease we will not get any drug action. So presence of structural changes. If drug or protein undergo any structural changes also, the protein drug binding will be decreased. So if any mutations and structural or chemical changes occurred in the protein will not bind to the drug, and this protein and drug binding will be decreased. And some disadvantages also there for protein binding. It will decrease the drug action, and if it is toxic, if the protein and drug binding is very strong, making the drug not making its action, and also if it will decrease its excretion. So if excretion is decreased, it will be stored in our body and it increase toxicity.